Okay. Midterm exam review. Okay, so there will be, again, 35 questions. And I'm going to, I'll make each one worth 3 points. So if you get them all correct, that will be 105%. So a little bit of extra credit built in there. Okay, so I'm just going to start off with maybe some, I don't know, general questions. So you should know kind of the conceptual definitions of the mean and the median. Mean, median, and standard deviation. So what are the conceptual, what's the conceptual definition of the mean? Not how do you find it or how to calculate it, but what's the conceptual definition of the mean?
Average.
Okay, the average, but well, I mean the mean and the median can both be thought of as the average, so conceptual definition of the mean is the idea of the balancing point, right? If you were to have a number line and you had to put the fulcrum somewhere in there, we've got that. Conceptual definition of the median. The halfway point. So half the data is bigger, half the data is smaller. Okay. Standard deviation. Spread, or it can be thought of as, yeah, maybe a typical, how far points are typically from the mean. So are they generally close to the mean? Are they generally far from the mean? Standard deviation gets that. So standard deviation, yeah, summarizes spread. You should know your empirical rule from the normal distribution. What's the empirical rule?
Wait, for a normal distribution?
Yeah. The empirical rule is kind of based on the normal distribution. What's the empirical rule?
68.
Yeah, 68 within 1 standard deviation, 95 within 2, almost everything, 99.7 within 3 standard deviations. Okay, and that gives us kind of a rough, good idea of whether our z-scores are extreme or not, right? Generally, z-scores larger than 2 or more negative than negative 2 are unusual. Anything larger or smaller than 3 or negative 3 is highly unusual. You know, how would you describe shapes of distributions? So, yeah, left skewed, right skewed, symmetric, multimodal, bimodals, unimodal. What do those things mean, right? The law of large numbers. So these are just kind of in the general question category. It's the law of large numbers. As the number of trials increase, your empirical probability approaches the theoretic probability. Empirical probability, that's the probability we observe from actually doing experiments, right? Okay, so then I have specific questions. All right, so reading a box plot. Okay, so when you read a box plot, you should be able to identify what? The median, Q1, Q3, IQR, and outliers. And make comparisons if you have multiple box plots, right? And make comparisons between box plots. Are we okay there? Do you want a quick review here?
For the box plots, is that when they're stacked on top of one another and you make the comparisons between where they're?
So box plot, you might have something that looks like this. And then another box plot that looks like this. Let's change this up a little bit. All right, so we'll call this 1 and 2. All right, which one has the higher median? 1 has the higher median. Which one has a higher max value? 2? Right? Where's the max value? It's, well, you know, we don't have any outliers here, but actually these probably would have been outliers here, but the max would be over here and the max would be over here for 1 and 2, right? The end of the whiskers, or if there's outliers, something like that, right? Okay. Which one has the larger IQR? 1. And how do we determine the IQR? It's the width of the box from a box plot. But yeah, it is Q3 minus Q1. We can determine the IQR just by looking at the width of the box, though. So that's nice. Hang on, I want to look up the actual thing that I have. Okay. You'll have some probability questions. So kind of your general probability stuff, probabilities of different events, or combinations of events. Probability tree questions. What else can I say about probability? Yeah, I think binomial probabilities. Okay. Then I guess I should talk about random variables. Okay, so the mean standard deviation of random variables Are there any questions on this stuff?
So wait, I'm sorry. With probabilities of different events in the combination, would that be like the independent versus the disjointed?
Yeah. So I'm trying to think of an example. Yeah, it could be something like the probability of A is 0.5 and the probability of B is 0.2. This is not an actual problem, of course. So we'll say if A and B are independent, what is the probability of A and B? So that would be A. Well, that would be A or B if they're disjoint. A and B, we would multiply these, right? So it would be the probability of A times the probability of, it would technically be B given A, but because they're independent, it's just probability of B. So I do 0.5 times 0.2, and I get 0.1. Oh, I'm sorry. Oh, sorry. One more under probability questions using a two-way table. To answer questions. So I think in this is also in your text with like the hair color and eye color. You had your table like this, right? You had like A and not A, and B and not B, and then 10 and 15 and 20 and 40 or something. Is that okay?
Yeah, the two-way table, that was the independent versus disjointed or dependent events, right? That's where...
You could ask questions of independent versus disjoint. You don't necessarily have to. So I could ask, what is the probability someone is A given he is not B? So this is like a terrible question because it's like, what is probability someone's A given not B? But how would we do this?
Well, would you find the probability of A and then probability of B and then...
So you given not B, right? So how many people are not B? In this table it's 60. And we want to know what's the probability someone is A. So it would be 20 over 60, which would be 1 out of 3 or 0.3333. Okay?
Yeah, that was like the hair example.
Yeah, exactly,
Okay,
exactly.
Sorry,
yeah.
sorry.
No. That's what this time is for, to make sure we got it. Any other questions on this? Okay. We'll also say, so you should know the normal model or normal distribution, both forward and inverse reading. have the normal approximation to the binomial. With continuity correction. And then we also have using the normal distribution to answer questions about a sampling distribution. Okay, so I mean, these are kind of like the questions you saw in today's quiz, I think. Yes?
Is R Studio coming down?
I'm going to have one question on R, and it's going to be kind of like the type of R-related questions that you saw in today's quiz. So there will be one R question, and it will cover either, you know, the use of D binom, P binom, P norm, or Q norm. And let me think.
For the note sheet,
Uh-huh.
we use our note cards.
I guess as long as the total surface area is less than 8.5 by 11, I'll be okay with that. I guess, let me think, 8.5 by 11 would be what? 988, I don't know, something. 92.5 or something, 93.5. So 3.5, 3 by 5 would be, okay, so I guess, is that 4 3 by 5s? 3 by 4 3 by 5s, front and back, would be equivalent to 8.5 by 11. I think that's 90 square inches versus 93.5. So, okay, so we'll say if you want to use your 3 by 5 note cards, you can have 4 of them, or 8.5 by 11. I think that's fair.
8.5 by 11, one side though, right?
Yeah, one side. Yeah, because 2 sides would be
Right.
double that. Okay. All right. Oh yes, confidence intervals. Of course. So confidence intervals you will see for 1 sample and for 2 samples. Know the construction and the appropriate conclusions. Okay, and I guess you should also know the, I guess, the labels of the parts. So, you know, what's the center, what's the margin of error, or what's the standard error. and what's the critical value. Obviously, you need to know all of these to create the confidence interval, but you should also know their names. Okay. Questions? So I think this covers pretty much all that will be on the exam. Yes.
Would you recommend that we just go over all the homework questions? again?
Yes, I would say study the homework, and I'll email out the blank quizzes and answers, and yeah, study the homework, study these topics. I would say so it always depends from class to class. Some classes have no issues with time, other classes do. So I would say work on, I guess you're making sure you can do things quickly enough. I think a hard thing is reading a question and then knowing exactly what you need to do next. That's probably what gets people hung up. Just they see it and then they have to think, how do I do this? So I'd say work on that part, okay? And then and you should be good. So work on speed, I guess. Don't buy a new calculator the day of your exam. That's always a terrible idea, okay? If you want a new calculator, get it now and make sure you practice with it before the exam. Okay, we'll see you guys next week at 7 o'clock. Good luck as you guys study.